we are going to be examining is exponents, right? Or equations that involve exponents, right? So now, so one of the key rules that we need to understand is that it is important that we firstly find prime factors. We find prime factors of this, right? So now how can we do to find prime factors, which means we are going to start here. Remember, this is going to be x3 over 2, which is same as what is 125. 125 is given as your 5 cube over what is going to be your this is the same as your 2 to the power of 2, right? This is given as your 2 to the power of, this is given as 2 to the power of 3. Now this is what we can find from here, right? And now from here, what is it that we can do is, remember, to get rid of 3 over 2, this x3 over 2, now what we can do here is we can multiply this by what? We can multiply this by our different, or rather our reciprocal. So which means this can be multiplied by 2 over 3 so that they cancel each other. However, what you do on the left, you also do it on the right. So which means here, because you have 5 to the power of 3 over 2 to the power of 3. Now this is still going to be the same as what? This is still same as 2 over 3, which is this 2 over 3 that we've multiplied on the side, right? So which means what you are going to have as your x here. Can you see that? And remember that both this 2 over 3 is also going to apply here, and it's also going to apply in both this, right? So which means, and when you multiply that, can you see that the 3 here and the 3 are going to cancel, and similarly 3 here and 3 here are going to cancel. So because look, when you're multiplying 3 multiplied by 2 over 3, the 3's are going to cancel, right? So this is going to be the same thing. So which means you're going to be left with 5 squared over 2 squared. And when you're left with that, which means actually your value of your x is going to be 5 to the power, or rather 25 to the power of, or 25 over 4, right? Because that's 5 squared, and also the other one that is 4 squared, right? So that is as far as this is concerned. Now let's see in terms of what else can we have. 3 over 4, which is equals to 1 over 2, right? This is what you are having. So now what is it that we are going to do is, look, the first thing that you can do is you can start by dividing, right? You can start by dividing by 4. And then what you do on the left will also do all right. Even this side, you're going to divide by 4, right? So which means now here, what you are then going to have, you are going to have this as x3 over 4, which is going to be equals to what? Which is going to be 1 over 8. Now, whenever you are dividing half with 4, it's actually 1 over 8, right? So, and now from here, what is it that you are going to do is, this is going to be x as 3 over 4. Now, from here, you can then write this. Remember, this 1 over 8 can be written as 2 to the power of 2 altogether. And from here, what we can do is we can then multiply both of these with the reciprocal here. And what is going to be reciprocal? It's going to be 4 over 3. And when you multiply by 4 over 3, you multiply by 4 over 3 everywhere. Remember this, it must be 3 because 8 is same as 2 to the power of 3, right? So then now, from here, what is it that you are going to have? This is going to be, now your x is going to be, what is 1 multiplied by 4 over 3 in your numerator? Still gives you 1. In your denominator, you same as you're having 4 over 3 multiplied by your 3. Can you see that? The 3's and 3's are going to cancel. So if the 3's and 3's are going to cancel, which means you are left with 2 to the power of your 4. And what is 2 to the power of your 4? Your x here, your x is equals to 1 over your 16. So now this is as far as this question is concerned. Now let's look at something else now. Now, let's say now I give you, or you are given that you are, let me fix this. Let's say you are given that now you have 4 multiplied by 9 to the power of x subtract 27 is equals to 3 to the power of 2x plus 1. They say now solve this question. What is it that you are going to do to solve this question? Remember, now it is important that you start again with prime factors. What are going to be the prime factors here then? Your 4. So you can leave this 4 for now and see. This 9 here, it's same as 3 squared to the power of x. Subtract what is 27. We can leave this 27 for now as it's in bracket. And then we can probably solve it later, right? Let's start with those ones that are a little bit, straightforward. This is going to be 2 to the power of 2x plus 1. And now from here, what is it that now we can have? Look, you can then take this and use this entire expression. Let me highlight this expression. You can take this entire expression here and transpose it this other side. So, and when you are transposing it this other side, what is it that you're going to have? So, which means you are going to have, look, this is going to be 4 multiplied by 3 to the power of 2x. Now subtract by 3 to the power of 2x plus 1. Remember, I've taken this equation this side, and I can then take my 27 this side now. This is going to be equals to my positive 27, right? So now what is it that I can have now from here? So can you see that if you can break these two down, now if you can break this down, if you can break this and also break this down, what is it that we can have? What you're going to have here, this is going to be 4 multiplied by 3 to the power of 2x, subtract 3 to the power of 2x, multiplied by what? Multiplied by 3 to the power of 1 is equals to 27, right? Because these, this represent, this still represents the same thing, right? And now from here, then we can take out the common factor. And what is going to be our common factor here? This is going to be a common factor, and this is going to be a common factor. And remember that this is separated by a minus. That's why we are going to take out the common factor. That's why we are not going to say we are multiplying. There's no multiplication, so you cannot add the exponent. So when you take out this as a common factor, you can take out now when you are taking this as a common factor, let's see, you take out what? As a common factor, you're taking 2 to the power of x. And then what you're going to be left with? Look, you're going to be left with 4 for the first one, right? The second one, we are left with 3 to the power of 1, which is this one, right? Which is that one. So that's what we are going to be left with. And now, when we are left with that, this is still equals to 27. So this is going to be 3 to the power of 2 x, and 4 multiplied by 3 gives you 1, which is equals to 27. Now you can say 3 to the power of 2x is equals to what? 27 can still be written as 3 to the power of 3. And therefore, what is it that you are going to be left with? Now you see that it's the same base, right? And since this is the same base, what is it that you can have here? So which means this you can have now 2x is equals to 3. Remember, when you have the same base, you can lose them and, write your exponent. This is going to be now what? Divide by 2 and divide by 2, which means your x is going to be equals to what? 3 over 2. This is the value that you are going to have as your x given. Right. So now what is it that we can do here? Right. Look, you can start by writing this in factor form. When you write this in factor form, this is 2 to the power of x multiplied by 2 to the power of 2 plus this one is 2 to the power of x multiplied by 2 to the power of negative 2 plus what? This other one is going to be 2 to the power of x, which is same as your 42. This is what you're given, right? So, and then now from here, can you see that here, let me get a highlighter. Here, can you see that this and this is going to be your common factor, right? Your 2 to the power of x. So if this is your common factor, so what is it that we can do? This is can be written as 2 to the power of x. You can take out 2 to the power of x as a common factor, and then you're going to be left with this, right? Remember, because it's separated by this plus, right? So then what you're going to be left with, it's 2 to the power of 2 plus this plus is this one, plus the other one is going to be what? Here you're going to be left with 2 to the power of negative 2, then plus 1, because in the last one you took the entire 2 to the power of x, so you're left with 1, right? And now this is still going, let's remove this. So this is still going to be same as what now? 2 to the power of x into, what is this? This is 4 plus what? This this can be written as 1 over 4 also, plus 1, which is equals to your 42. And then now, how can we then continue to solve this? This is going to give us, we are going to have 2 to the power of x. And if you add 4 plus a quarter plus 1, this is going to be 5 and a quarter, right? This is going to be 5 and a quarter, right? Which is equals to 42, right? Then you divide by this 5 and a quarter, right? On both sides. You can start by dividing with this on both sides, right? So remember, because you are solving for this, so you can divide by this in both sides. This 5 and a quarter, right? And then you divide by 5 and a quarter on both sides. I mean, and a quarter, right? And what is 5 and a quarter? 5 and a quarter, it's same as 21 over your 4. So you can divide by that if you don't want to write this as 5 and a quarter. And then what you're going to have, you're going to be left with 2 to the power of x, which is equals to same as 8. And how can you write 8? Remember, you're not allowed to write this because we haven't solved even this one. So this is going to be same as what now? 2 to the power of x, which is same as 2 squared, 2 to the power of 3. And then this, the bases are the same. So this is going to be same as what? Let's write here. This is going to be same as x is equals to 2. This is going to be your solution. So this is as far as this question is concerned. X is equals to 3, not 2. Remember, because this is to the power of 3, not 2. Right? Now let's add and check another one. Look, we can start by writing this into factor form this here. Or rather, let me highlight it like this, right? So we can start by writing it into factor form. And how can you write this in factor form? This is going to be not 2. This is going to be 5 to the power of x multiplied by 5 to the power of 2 plus what is going to be this? This is 5 to the power of x is equals to 108. Then you take out 5. Can you see that 5 to the power of x and 5 to the power of x is your common factor? So if this is your common factor, what you are going to have is you are going to have 5 to the power of x into bracket 5 to the power of 2. Remember, because this 5 to the power of 2 is what is left, plus 1, because if you've taken out the 5x, you're left with 1 as equals to 130. So now after here, this is going to be 5 to the power of x. 5 to the power of x, which is going to be same as, what is this? This is going to be same as now 25 plus 1 is equals to 130. And now let's make up some space here. So now, and then how can you solve this? This is still going to be 5 to the power of x is equals to what? Or 5 to the power of x into brackets 26 is equals to 130. And now from here, this is going to be same as 5 to the power of x 26 divide by 26. Remember, you divide by 26 here so that you get rid of this 26. You come this side, 130 divide by 26. These two are going to cancel, which means this is going to be 5 to the power of x is going to be equals to what? What is 26 divided by that? This is same as 5. And remember, 5 is actually same as 5 to the power of 1. And these bases are the same, which means this is going to be x is equals to 1 as your solution, right? Then what is it that you are going to have here? So you can start by writing this in vector form. This is 2 to the power of x multiplied by 2 to the power of 1 plus 2 to the power of x multiplied by 2 squared is equals to 192, right? So what is it then that we can do? Yes, we have a common factor. This is common. This is common. So when you have a common factor, what is it that we can do? We can then go back. We can take out 2x as a common factor. Then you're going to be left with what? 2 to the power of 1. Remember, you're left with this 2 to the power of 1 plus what? 2 to the power of 2, which is this one, is equals to 192. Then what is that? This is the same as 2 to the power of x into brackets. This 2 to the power of 1, it's same as 2. Then which means 2 to the power of 2, it's 4. So which means the totality of this is going to be 6, which is equals to 192. I'm not sure why the 6 always comes back. So this is 2 to the power of x now, which is going to be 192 divided by 6. Remember, we are dividing by 6 so that we remove this 6 here, right? So this is going to be 2 to the power of x now, which is this is going to be 2 to the power of x, which is going to be same as 2 to the power of, what is this? This is going to be 32. The answer for this is going to be 32. And 32 is same as 2 to the power of 5. So can you see that the 2's and 2's are the same? So which means our x is going to be equals to 5. So this is as far as this question is concerned. Thank you very much.